In this question, we're asked to determine an exponential function that passes through the points 0, 15, and 5, 480. We also want to know what the exponential growth or decay rate is. We also want to find the function value when x equals 2. If an exponential function is in this form here, then the base b is equal to 1 plus r, where r is the growth or decay rate expressed as a decimal, a is the initial value, or the function value when x equals 0, and x is the exponent. So if our function contains the point 0, 15, this means f of 0 is equal to 15. So 15 is the initial value, or equal to a. And if the function contains the point 5, 480, then f of 5 must equal 480. And to emphasize that a is equal to 15, we can replace x with 0 in the exponential function. If we did this, we would have a times b raised to the 0 power equals 15, but b to the 0 is equal to 1, so we know a must equal 15. Now we can use a equals 15 and the fact that f of 5 equals 480 to determine the value of b, our base. So we'll substitute 5 for x, so we know a is 15 times b to the 5th power must equal the function value of 480. So now we'll solve for b, so we'll divide both sides by 15. We have b to the 5th equals 32. We want b, not b to the 5th, so now we'll take the 5th root of both sides of the equation. The 5th root of b to the 5th simplifies to 1 factor of b, and the 5th root of 32 is equal to 2, because 32 is equal to 2 to the 5th. So this simplifies nicely to 1 factor of 2, which means the exponential function that we're looking for that passes through these 2 points is f of x equals a, which is 15, times b, which is 2, raised to the power of x. Now if we want to check this, we could graph this function to make sure it passes through these 2 points. Let's go ahead and do that. Here's a graph of our function in blue, and here are the 2 points that we were given. Notice how our function does pass through these 2 points. This verifies that our function is correct. But now we still want to find the exponential growth or decay rate and also the function value at x equals 2. We can determine the exponential growth rate since the base b is equal to 1 plus r, where r is our exponential growth or decay rate expressed as a decimal. Since the base is 2, we know that 2 must equal 1 plus r. Subtracting 1 on both sides, r is equal to positive 1. Well, 1 expressed as a percentage would be 100%, which means the exponential growth rate is 100%. Which means each time x increases by 1, the function value will increase by 100%. But I also want to point out that notice how the base is 2, so as x increases by 1, we're multiplying by another factor of 2, which means the function value will double each time x increases by 1. So having an exponential growth rate of 100% is the same as the function value doubling each time x increases by 1. And now for the last question, we want to find the function value when x equals 2, so we need to determine the value of f of 2. Well, f of 2 is going to be equal to 15 times 2 squared. Well, 2 squared is 4. 4 times 15 is equal to 60. Notice from the initial value of 15, the x value increases by 2, which means the function value of 15 would double twice or increase by 100% twice. So if we start with 15 and we double this or increase it by 100%, that would be 30. If we take 30 and double it or increase it by 100%, that would give us a value of 60, which is our function value f of 2. Okay, I hope you found this example helpful.